The shell formula for around the x-axis. The shell formula for rotating the region between two graphs around the x-axis is given as the volume is equal to the integral from c to d of 2 pi y g of y dy, and volume is equal to the integral from c to d of 2 pi y g of y minus h of y dy, where g of y is equal to or greater than h of y for y an element of the closed interval from c to d. That's just a complicated way of saying right function minus the leftmost function. Example, find the volume of the solid obtained by rotating the region under y equals 9 minus x squared on the closed interval from 0 to 3 over the x-axis using cylindrical shells. Let's begin this problem by getting a graph of y equals 9 minus x squared from 0 to 3. And remember, we want to rotate cylindrical shells about the x-axis. So for our shell or cylindrical shell formula, we'd have the volume is equal to the integral from c to d, 2 pi y g of y dy. With that said, we're going to need to solve y equals 9 minus x squared for x. So for y equals 9 minus x squared, we get x as the square root of 9 minus y. Now we can get the volume integral in terms of y. That will be the integral from 0 to 9 of 2 pi y, and for g of y, we're going to have the square root of 9 minus y dy. The remainder of this problem is just obtaining the integral. To do this one, let's go ahead and re-express the square root of 9 minus y as that raised to the power of 1/2. The integral from 0 to 9 of 2 pi y, and in parentheses 9 minus y raised to the power of 1/2 dy. We need to do a substitution. The key is to find the inside function of a composite function. We're looking at 2 pi y. The 2 pi is a constant, so we'll ignore that for a moment. Then you have y, and the quantity 9 minus y raised to a power. The 9 minus y is the inside of the composite function, so let's let u equal the 9 minus y. We'll take derivatives. The derivative of u will get du, and for 9 minus y, we get minus dy. Remember though, we have a positive dy in that original integral, so we'll multiply through by a negative and get negative du equals the positive dy. In the substitution, we need to express all y's in terms of u, and so where we have u equals 9 minus y, we'll solve for y, and that'll give us y equals 9 minus u. We've got one more thing to do before we can make the substitution. That is, we need to get the substitution bounds of the integral. We let u equal 9 minus y. The lower bound of integration with respect to y is 0. We need to get that with respect to u. So u would be equal to 9 minus where the y was. We replace it with 0. The lower bound is 9. Similarly, for the upper bound, we'll have u is equal to 9 minus 9, and that's equal to 0. Now we've got the information we need to write the integral with our substitution. We begin. The negative outside of the integral is in place because we had to put in negative du for the dy. The limits of integration, we just solved for them. we're going to go from 9 to 0, 2 pi where y was with respect to u, that'll be 9 minus u, and where 9 minus y was raised to the 1/2, we let u equal 9 minus y. So the 9 minus y to the 1/2 becomes u to the 1/2 du. Let's factor out the 2 pi and multiply the u to the 1/2 through 9 minus u that is distributed. That'll take us to negative 2 pi, the integral from 9 to 0 of 9 times u to the 1/2 is 9u to the 1/2 minus u times u to the 1/2, adding the exponents together, that's u to the 3/2 du. Now we'll use one of the special properties of integration that lets us switch the lower and upper limits of integration by changing the sign. So from negative 2 pi, the integral from 9 to 0, and we will write that as a positive 2 pi, integral from 0 to 9 of the quantity 9u to the 1/2 minus u to the power of 3/2 du. Let's integrate and evaluate. The 2 pi is the constant. 9 times the integral of u to the 1/2, that would be u to the 3/2, and the constant associated with that would be 2/3, minus the integral of u to the 3/2, add 1 to 3/2, that'll give you 5/2, so u to the 5/2, and the constant associated with that would be 2/5, and we evaluate that from 0 to 9. Let's do some arithmetic if it's helpful. So we're going to have 2 pi times 9 times 2/3 is 6, u to the 3/2 minus 2/5 u to the 5/2, still evaluated from 0 to 9. We'll put in 9 every place there is a u in the integral. Don't forget the 2 pi. And then in parentheses inside the brackets, we'll have 6 times 9 to the 3/2 minus 2/5 times 9 to the 5/2, and it's minus 0. 6 times 0 to a power is 0, 2/5 times 0 to a power is 0 as well. We'll continue with the arithmetic portion. We get 2 pi, 6 times 9 to the 3/2 is 27, minus 2/5 times 9 to the 5/2 is 243. Continuing, 2 pi times 6 times 27 is 162, minus, let's multiply 2 to the 243, so that fraction is 486 divided by 5. Get a common denominator and combine. So we'll get 2 pi times 3/24 and multiply the 2 pi through, and our volume will be 648 pi divided by 5.